in this world is static, as the landscape of the universe evolves with every second of every day. The second law of thermodynamics sums it up, stating that any isolated system, such as the universe, will naturally increase in entropy or disorder over time. Order takes effort, but disorder is natural, and chaos inevitable. All of this, though, governed by other laws of physics. Entropy happens within certain parameters, and we also know that everything has its limits. One day, every animal dies, every star is extinguished, and every black hole eventually disintegrates, in a few trillion years or so. Scientists depend on the laws of physics, then, to remain static and unchanged compared to everything else, because without them, the universe becomes so much more unpredictable. But there's no real reason that physics has to be the same everywhere. We expect it to remain the same in our universe, in our isolated system. But what about beyond? It's why so many stories set in a multiverse include different realms and dimensions with totally different physical properties. So what would happen if we learned how to change our own seemingly immutable laws in the here and now? Today, for example, we can confidently say that you can't go faster than the speed of light and you can't fall upwards from Earth. You definitely can't combine the two and fall upwards from Earth at faster than the speed of light. These particular feats are impossible because physics won't allow it, and that's the reality we live in. But with the power to change physics, there'd be no such thing as impossible anymore. It would now be as though we were designing a video game, only the game is our very existence. Anything is conceivable in games because developers build into them the virtual world physics to determine how objects interact with each other. In most cases, they opt for mimicking real-world physics, or as close to it as possible, to ensure that their product is realistic for the player. But grant that same level of control to humans over life, and why should normal rules still apply? Now we'd be the developers of life. We'd all have this higher power, transforming us into ultra-advanced beings. And falling upwards from Earth at faster than the speed of light is now back on the menu. Practically speaking, there'd be nothing we couldn't do. At the small end of the scale, say you needed to move house. Swap Earth's gravity for something like the moon's, and suddenly all of your furniture is 6 times lighter. Even with a grand piano, all you'd have to worry about is keeping it from floating off the moving truck. Imagine then that in your new house, the heater breaks down in the middle of winter. Again, no problem. You'd simply alter the first law of thermodynamics and regenerate the heat. Now, contrary to what this law traditionally tells us, energy can be created or destroyed, which, more broadly speaking, basically puts unlimited energy into our hands. No need for electricity to run things like microwaves or vacuum cleaners. Just create the energy yourself and job done. Turn all that endless energy onto your own body, though, and the really exciting stuff starts to happen. Without the first or second laws of thermodynamics to limit us, there's a bottomless pit of energy coursing through our arms and legs and brains. We might use it to unlock superintelligence. Aided by a few further tweaks to gravity, we could choose to be able to fly. Or maximize how the very cells and atoms in our bodies work, and we could slow the aging process indefinitely, perhaps even to the point of immortality. Because Albert Einstein showed us that matter and energy are interchangeable, it also follows that without the first law of thermodynamics holding us back, we could create matter out of nothing as well. Fancy a bowl of spaghetti? Make it for yourself from subatomic scratch, and then warm it to just the right temperature by creating all of the energy needed. Entire universes of your own design could be built this way, made completely out of spaghetti if you wanted to, without any consequence for physical reality. In this world, if you want it, you got it. This is about more than just pasta, though. One of the greatest questions in all of modern science is whether or not we're alone in the universe. Currently, it's such a difficult question to answer because physics makes the immensity of space nearly impossible to fully explore. Just getting rockets off the ground requires a tremendous amount of energy to overcome Earth's gravity. If we could change the laws of physics, though, even space travel gets easy, and a rendezvous with aliens becomes more feasible. Rearrange reality so that the rocket is near weightless, then make it so that there's zero friction along its route through the atmosphere, and taking off is as simple as 3, 2, 1. Alternatively, change Newton's laws of motion so that rockets can accelerate without an outside force acting on them, and we're reaching the highest possible speeds without even needing fuel. Then, by altering the highest possible speed, the speed of light in a vacuum, another previous impossibility that we could now totally do, we could raise the uppermost limit for travel and open the door to boundless exploration. Right now, even if we could travel at light speed as it is, it would take us 25,000 years just to reach the nearest galaxy to us. When we contemplate space as a whole, physics is a real pain like that. But in an alternate world where the laws of physics change, vast distances are so much more bridgeable, light years aren't even a thing, and there's really no issue. But it's not all fun and games. And while all of these incredible life hacks might seem beneficial, there would be problems too. Big problems. Our universe might seem stable, and it has been around for billions of years, but it's still incredibly precarious. The fine-tuning problem in physics suggests that the way the universe is structured is actually so very unlikely. It shows that certain values in the cosmos, things that we don't usually think about all that much while we're busy living our lives here on Earth, must be and must remain near exact to work. If they don't, it all falls apart. For example, a slight alteration in the masses of up and down quarks, the building blocks of matter, could then affect the stability of protons and neutrons and cause atom structure to irreversibly change. A disaster for anything made of atoms, which is everything. Alternatively, it's calculated that changing in any way what's known as the weak force, one of the fundamental forces in physics, could cause star formation to cease and eventually plunge the universe into darkness. Even altering the most mainstream law of physics, gravity, could have severe consequences. Accidentally raise it too high, and you could find yourself crushed in an instant. Lower it too far, and you might inconveniently float away forever. Change gravity over a wider area, and you could even begin to break apart planets and star systems and galaxies. Next, our control over the first law of thermodynamics, where we were creating energy and matter at will, might have seemed like a big positive, but you can quickly have too much of a good thing. Because mindlessly generate too much matter in one spot, and you could well spawn a black hole, which would swiftly proceed to tear you and everything for hundreds of thousands of miles around you apart. Spaghettified, but this time it's really nothing to do with food. And finally, the jump from these kinds of massive cosmic disasters to the potential weaponization of physics for some kind of high-level warfare isn't a big one to make. If we could change physics, then suddenly meteors become bullets. Long-range missiles travel the length and breadth of a galaxy in seconds. And contaminating even the air we breathe becomes a flick of the switch maneuver to pull against the enemy. The universe mutates over and over, turning into an increasingly violent and deadly place. So this one's a tale of two distinct halves. On the one side, there's all the fun we could have, video game style, if the laws of physics weren't set. And there's the potential for immortal life, too. But on the other, there's death and destruction. And because of the fine-tuning problem, there's the possibility that none of this would even be possible at all. It's said that with great power comes great responsibility. And it's also said that some rules just aren't meant to be broken. Both ring true here, because that's what would happen if we could change the laws of physics.